So students, in the previous classes we have seen the problems on normal distribution. But here, when the number of trials are very large and here they have given the probability of success and probability of failure, then we can't apply the binomial distribution. Then in that case, when the number of trials are indefinitely very large, then the normal approximation tends to the binomial distribution here. So here also we have two cases. When the probability of success and the probability of failure both are equal chances, means both are unbiased here. As we know that here P is the probability of success and Q is the probability of failure for the binomial distribution, and moreover P is known as a parameter of binomial distribution. So when both have the equal chances, then we have Z equal to x minus mu by sigma, where mu is nothing but the mean of the binomial distribution and sigma is nothing but the standard deviation of the binomial distribution, right? So we have to substitute the mu value in this standard normal variate Z and we have to obtain that. But the second case is here when both the probability of success and probability of failure are not equal, right? Then also we need to find the probability of in between random variables. Then here Z1 is given as x1 minus 1 by 2 minus mu by sigma, right? And Z2 is given as x1 plus 1 by 2 minus mu by sigma, where here also mu is nothing but the mean of the binomial distribution and sigma is the standard deviation of binomial distribution. And we know the formulas of probability of Z1 when Z1 is less than 0 and when Z1 is greater than 0, right? So these are the conditions when the normal approximation tends to the binomial distribution here. So remember here, when in a random experiment both the probability of success and failure has equal chance, then we have to use the original formula of the standard normal variate. But when both are biased here, then we have to consider Z1 equal to x1 minus 1 by 2 minus mu by sigma and Z2 equal to x1 plus 1 by 2 minus mu by sigma. Now let us see the problem on binomial distribution when the number of trials are indefinitely large. Now see the problem here. Find the probability that out of 100 patients between 84 and 95 inclusive will survive a heart operation given that the chances of survival is 0.9. So here only the chance of survival is given and the number of patients are 100, means indefinitely large. So we can't apply the binomial distribution. So automatically we have to shift to the normal distribution here. And also here the table values of the ordinates are given here, right? So if you come to the solution here, so number of patients are 100, that means n equal to 100 and the chance of survival is here 0.9. If P represents the probability of chance of survival, then it is 0.9. Then Q represents the probability of not survival. So 1 minus P, that is 1 minus 0.9 is 0.1 here, right? So then here, as we know that the mean of the normal distribution becomes the mean of binomial distribution, that is here 100 into 0.9 is nothing but 90 and sigma is nothing but square root of NPQ. So that is n into, means here 100 into 0.9 into 0.1 here. So 100 into 0.9 into 0.1 is 9 here. So that is nothing but 3. So the standard deviation is here 3. Now we have to find that probability of out of 100 patients between 84 and 95 inclusive will survive a heart operation. That means probability of 84 less than x less than 95 we have to find here. So that means here x1 equal to 84 and x2 equal to 95. So if you see here the chance of survival is not biased here. So is biased. That means the chance of survival is 0.9 and the chance of not survival is 0.1. That means P and Q are not equal. So therefore Z1 is given as x1 minus 1 by 2 minus mu by sigma and Z2 is given as x2 plus 1 by 2 minus mu by sigma here. So if we substitute here 84 minus 1 by 2 means 0.5 minus mu value is here 90 by sigma value is here 3. Similarly, for Z2, X2 means here 95 plus 1 by 2 means 0.5 minus 90 by 3 here. Now let us simplify this using calc. So 84 minus 0.5 minus 90 divided by 3 is minus 2.16. So minus 2.17 here, right? And similarly here Z2 is 95 plus 0.5 minus 90 by 3 is 1.83, right? So here Z1 is less than 0 and Z2 is greater than 0 here. So we are finding probability of x1 less than x less than x2. So Z1 is less than 0 and Z2 is greater than 0. Then probability of 84 less than x less than 95 is given as here A of Z1 plus A of Z2. So that means here A of Z1 is area value of 2.17 is 0.4846 plus area of 1.83 is 0.4664. So if we add these two here, 0.4846 plus 0.4664, it is 0.9510. So the probability that between 84 and 95 patients will survive from the heart operation is 0.9510. Let us see one more problem on this. Find the probability that by guesswork a student can correctly answer 25 to 30 questions in a multiple choice quiz consisting of 80 questions here. Answer: assume that in each question with 4 choices only, one choice is correct and the student has no knowledge of the subject. And here the table values, normal table values of the ordinates are given here. So here totally 80 questions are there, that means n equal to 80, right? So each question has 4 choices, but definitely out of 4 only one will be the right answer. So that means here if P represents the probability of right answer, then P equal to here 1 by 4, that is nothing but 0.25. When P represents the probability of right answer, then automatically Q represents the probability of wrong answer, that is 1 minus P, 1 minus 0.25 is 0.75 here. Then here the mu is given by NP, that means 80 into 0.25 is equal to 20 and sigma equal to square root of NPQ, means the standard deviation of binomial distribution. So 80 into 0.25 into 0.75. So this is equal to here 80 into 0.25 into 0.75 under the square root is 3.87 here. So sigma is 3.87. Now we have to find that the student can correctly answer 25 to 30 questions. That means probability of 25 less than x less than 30 we have to find here, right? So x1 is 25 and x2 is 30, right? And here also the P and Q values are not equal. So Z1 is x1 minus 1 by 2 minus mu by sigma and Z2 is x2 plus 1 by 2 minus mu by sigma here. So x1 is here 25. So 25 minus 0.5 minus mu value is here 20 by 3.87 is the standard deviation. And here also Z2 is x2, x2 means 30, 30 plus 0.5 minus 20 by 3.87. Now if we simplify here, Z1 will be 25 minus 0.5 minus 20 by 3.87 is here 1.16. So it is 1.16. Remember here it is positive, right? Greater than 0. Now coming to Z2 here, 30 plus 0.5 minus 20 by 3.87. So it is 2.71. So this is also greater than 0. So we are finding probability of 25 to 30 questions. So Z1 is greater than 0, Z2 is also greater than 0. So the formula is modulus of A of Z2 minus A of Z1. So A of Z2 means here area value of 2.71 is 0.4966 minus area value of Z1, that is 1.16, is 0.3770. So this is under modulus. So it is 0.4966 minus 0.3770 is 0.1196. So the probability that a student can answer 25 to 30 questions out of 80 questions is 0.1196. So in this way we can solve the binomial distribution problems when the number of trials are indefinitely large.